Hello everyone, this is Coder2J. In today's video, we'll explore the powerful world of Spark SQL and SQL operations with PySpark. Let's get started. Spark SQL is a Spark module that facilitates querying structured and semi-structured data using SQL commands. It extends Spark's capabilities to handle structured data and allows users to seamlessly switch between SQL queries and Spark's core APIs for data processing. Here are the key features of Spark SQL. Unified data processing. Spark SQL provides a unified API for both batch and real-time data processing, making it easier to build end-to-end data pipelines. Schema inference. It can automatically infer the schema of structured data sources, reducing the need for explicit schema definitions. Data source abstraction. Spark SQL supports a wide range of data sources, including Hive, Parquet, Avro, ORC, JSON, and JDBC, making it versatile for working with different data formats. Integration with Hive. It can seamlessly integrate with Apache Hive, allowing you to run Hive queries and access Hive UDFs within Spark SQL. Let's do a step-by-step demo on how to perform SQL-like queries on DataFrames in PySpark. First, initialize a Spark session. To get started, you need to initialize a Spark session, which is the entry point for using PySpark's SQL capabilities. Here's how you can create one with a proper app name like DataFrame SQL. Second, load data into a data frame. You can load data into a data frame from various sources like CSV, Parquet, JSON, or Hive tables. For this example, let's use a CSV file named persons.csv with a header and columns of name, age, gender, and salary. Third, register the data frame as a temporary view. To run SQL queries on the data frame, you need to register it as a temporary view. We can simply achieve that by using the method createOrReplaceTempView and giving it a name like my_table. Fourth, perform SQL-like queries. Now that you've registered the data frame as a temporary table, you can use SQL-like queries to analyze the data. For example, we can select all rows where age is greater than 25. Or computing the average salary by gender with SQL queries. To view the results of your SQL queries, you can use the show method. Creating and managing temporary views. In PySpark, you can create and manage temporary views to work with data frames using SQL-like syntax. Like what we already did, to create a temporary view from a data frame, you can use the createOrReplaceTempView method. This method registers the data frame as a temporary table that you can query using SQL-like syntax. For example, we can create another temporary view named people. Once you have created a temporary view, you can query it using SQL-like syntax with the Spark.SQL method. For example, getting all the rows with age more than 25 by querying the temporary view. You can check if a temporary view exists using the Spark.catalog.tableExists method. This can be useful before attempting to create or query a temporary view. Lastly, dropping a temporary view. To remove a temporary view when you're done with it, you can use the Spark.catalog.dropTempView method. This frees up resources and removes the view or table from the catalog. Using advanced SQL operations for data analysis. In PySpark, you can leverage advanced SQL operations to perform complex data analysis on data frames using SQL-like syntax. These advanced SQL operations can help you gain insights, perform transformations, and solve more intricate data manipulation tasks. Here are some examples of advanced SQL operations in PySpark. First, subqueries. Subqueries are nested SQL queries that can be used within another query. You can use subqueries to filter or aggregate data based on conditions from another table or subquery. Here we create two data frames called employees with ID and name, then salaries with department, ID, and salary. Let's register them as temporary views. Then we can use subquery to find employees with salaries above average. Here, we use the query to get the average salary in the salaries table. Then use it as a subquery to select the ID of the employees whose salary is above the average. Then use the whole query as the subquery to get the employee name from the employee table. Second, window functions. Window functions allow you to perform calculations across a window of rows defined by an ordered partition of the data. Common window functions include row_number, rank, dens_rank, sum, avg, and more. In this example, we will calculate the rank of employees within each department based on salary. Let's first join the table employees and salaries to have a data frame called employee_salary with columns department, employee ID, and salary. Then we create a window specification of partition by department and order by salary descending. Then we create a rank column to rank based on the window's specification. From the result, we can see the rank of the employee's salary within each department by salary. These are just a few examples of advanced SQL operations you can perform in PySpark. In the end, we need to stop the Spark session as a best practice. Congratulations! You've just learned what Spark SQL is and SQL operations with PySpark. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell. Thanks for watching, and see you in the next video.